X squared minus 6x minus 9.
Very good. Now you have to set it equal to 0, and this is where your prerequisite classes come in. Hopefully you see that you can factor a 3 out of everything.
Yeah.
Now, do you remember how to factor this?
After I factor, yes, I'm pretty sure.
So two
um,
numbers that multiply to -3 but add to -2.
so -3 and 1.
Very good. Now you only set the x terms equal to 0,
Okay.
or they're actually not terms. They're whatever. They're the things in parentheses, um, factors. Um, so you set those equal to 0. Um, solve for x. Now there's
Yep.
two ways to proceed from here. There's the first derivative test, and then there's the second derivative test. Do you remember what you were doing in class? The first derivative test is where you make a number line, a sign chart.
We did both.
Okay. Um, so I guess I'll show both, and then you can kind of decide problem by problem which one you want to do.
Okay.
You put the two critical points on a number line, and this is where students uh, focus too much on the um, the actual evaluation of it. So you pick points that are not on the number line, and you notice like I've labeled them sort of down here away from the number line so we don't get mixed up with that. Now you
Okay.
test these in the derivative, which if you look back, we have like the standard form, slightly factored, fully factored. It's actually easiest to go to the fully factored form, and you only care about whether it's positive or negative. You don't care what the actual result is. So I know like the tendency is like you put 4 and you're like, all right, 4 minus 3 is 1, and 4 plus 1 is 5, and 1 times 5 times 3 is 15.
Yeah.
But if you want to do this quickly, and I know quickly isn't always the good strategy, but you actually care. I've got a positive 3. When you put 4 and that's positive, that's positive. Positive times positive is positive.
Yeah.
Okay. When you put 0 in, positive, 0 minus 3 is negative, 0 plus 1 is positive. Positive times positive is negative. Negative
And
2, positive times a negative, that's -5 if you care. -2 plus 1 is negative. Positive times a negative is a
positive.
positive. Okay. All right. So a couple of things here that's really important. These do not always alternate. They do alternate for polynomials most of the time, but not always. Please don't make that mistake of thinking they always alternate. Please test the values.
Okay.
Second thing, and this is to memorize, if you go plus to minus, that's a max. Minus to plus is a min. And you might have seen students in class, or maybe the teacher, like with their finger showing like up is the plus to a minus, that's the max. Minus is going down, then to plus, that's a min. So this is to memorize. Plus to plus, minus to minus is nothing. I mean, it's not nothing, but it's not a min or a max. I mean, it
Yeah.
is something that it's, so okay.
And so
That
is the min or max? Is the min or the max at -1 or 3?
yeah. So at 1, it's a a max, relative max. At 3, it's a relative min.
Okay. So
So critical point is where the derivative equals 0. Because there's a lot of questions they could ask you for this problem. They could ask you like, what are the critical points? The critical points are -1 and 3. They could
okay.
ask you, is there a min? Is there a max? Yes, there's a max at -1 and a min at 3. They could also ask you, what is the min or max? What is the min or the max? And you have to put the x value back into the original function.
Okay.
These are only the where is it, not the what is it. And then like we just said, there's the second derivative test. So let's quickly look at that. This is probably the easiest example to explain on it. So it will typically say on a test or a quiz, like use the second derivative test.
And the second derivative is for like concaves, right?
Well, it's for critical points as well. So
Oh,
your derivative is second derivative is 6x minus 6. Okay, is that
yep.
okay?
Yes.
Now this again, this is kind of off to the side. If f double prime of c, that's your critical point, is less than 0, that's a max. F double prime of c is greater than 0, that's a min.
Okay.
So you had two critical points. You had one at 3,
Yeah,
negative
three and
1 and
negative.
3. So we have to evaluate both of them in the second derivative. 6 times negative 1 minus 6 is negative 12, but you only care that it's less than 0. That is a max. Is that what we said earlier? Did we say that minus 1 was a max? We did.
Okay.
Okay. And then same thing, f double prime of 3. 6 times 3 minus 6 is 12, which is greater than 0. That's a min. So they are consistent.
Okay.
Are you planning to take more math? Like, not necessarily next year, but like, do you feel like you'll go into STEM where you might take calculus 3?
Probably.
All right, so in calculus 3, you do a similar calculation with partial derivatives, and you end up doing this kind of stuff like all over the place. They call it the Lagrangian method and a few other things. So if you really think you're going to take more math, the second derivative is kind of the way to go. Plus, it forces you to take another derivative. It's
Okay.
easy to make mistakes in the sign chart, truthfully.
Yeah.
Okay, so that's like your starter warm-up example. We'll now tackle some of your problems.
Okay.
Um, does that make sense
Yeah.
to do? Okay. Um, I typically try to stay away from the odds, but this is a good one for us to look at. Um,
Okay.
so you have to be able to take a derivative of this. Like by this point in the course, you should be able to take a derivative of everything without question. If you have questions, please ask, but could you take a derivative of this and simplify as much as possible also?
Okay, I got 3 e to the x minus e to the x plus e to the x. Oh,
Okay.
wait, that's wrong. X e to the x. That's a product rule.
It is product rule, so just be careful with that. Wow, this is really
So,
weird. Let me know when you got it. I don't want to jump in. It's important that you can take a derivative here.
I got 3 e to the x minus e to the x plus x e to the x.
So this is really in parentheses. Does that change your answer?
No, because isn't that product rule?
So it should be a negative in the second one. So it's 3 e
Oh,
to the x minus, like you said, e to the x minus x e to the x. So
okay.
minus e to the x plus x e to the x. So 2 e to the x plus x e to the x. And then like depending on what you're doing, sometimes you rewrite this. So this is where like the more your prerequisite courses can help you here. So you're setting this equal to 0. E to the x never equals 0, but 2 plus x does.
Okay.
Sorry, except I've got a sign error here. I'm so sorry. That's the second one is minus. I'm talking about this and I'm the one doing it. That's really bad. Really, really bad. Okay. This is your paper even said it said at 2. So I was like, ah, didn't work. All right. So e to the x never equals 0. Graphically, e to the x looks like that. Never equals 0, but this one does. So, this is where you got to decide, like, do you want us to do a sign chart? I think it'd be good to do for this one.
Okay.
So the question is always, well, what points do I test? 0 and 1 are always really good. Um, just pick something away from it. So
Okay.
now the other question is, well, where do you test it? And you actually have any of these 3 lines you can test, or even this first one. I like the
Okay.
factored form. One of the things to notice about e to the x is always greater than 0.
Okay.
Like the graph is always above the x-axis. So when you put 0 in there, I know it's 1, but you can think positive, always positive. So it really comes down to the sign of this one. 2 minus 0 is question.
No, no, no.
Okay.
You're good.
Okay. But I know as a student, you want to calculate and get the number. If you can try to not do that, you will be far ahead of the other students in your class,
Okay.
which I know goes against all the things you've been taught, but that's anyway. So is this a min or a max?
That's a max.
Goes up, comes down, so it's a max. So you could say, I mean, it's like this, it's a max at x equals 2, but to actually get the max, that's where you have to go back to the original function. And I think it was like 3e to the 2 minus 2e to the 2. Yeah.
Yeah.
And so that's what it is. It's just e squared, and that's okay. You will see problems like this on the AP.
Okay.
Any questions on that?
Nope.
So the reason we might not do the second derivative is because it's more stuff, more derivative, more product rule. Um,
Yeah.
but it's possible. Um, the teachers tend to like make you do it on one problem or another.
Yeah.
Okay, let's look
Um,
at 22.
okay.
Oh, I don't really like 22. It's more complicated than it needs to be.
Okay.
Uh, like it's not a great trig function. Did you get
Yeah.
any other problems to like what do you know what kind of problems you're getting in
Um,
class?
those are kind of like the only problems that we're really getting. Hold on. I can look at my. We haven't really done much on this like lesson. We did like a AP practice worksheet with some questions,
Okay.
but I don't have it. I had to turn it in. Shoot.
The reason I'm asking is because I don't know how complicated to make these, and I also well, I don't want to distract from what we're doing. So I think we should actually keep it a little bit more simple. So let me
Okay.
find another problem here that I think would be reasonable for us to do. Um, okay, and then we'll do a few more of these, and then we'll look at some graphs. That's also important.
Okay.
Okay, could you take the derivative of this for us, please?
Yeah. I got 2x times ln of 3x plus x squared times 1 over x or over x.
Okay, do you want to simplify any of that?
Preferably not. Or the
Okay.
x squared and the x, can't we cancel out one of them?
Yes, yes, that should at least be done. Okay, I agree. 2x natural log of 3x plus x. Now set this equal to 0. You always try factoring. Can anything factor out?
Um, we can factor out x,
Tell
right?
me what goes in parentheses.
Uh, 2 ln of 3 plus 1
3x.
plus 1. Okay.
All right. Now, we didn't talk about this, but the original problem, its domain is restricted. Did you guys talk about that at all in class?
No.
Okay. And that's an important thing here because it's not a number line from 0 to infinity. It actually starts at 0 and goes to infinity because
Okay.
natural log is only defined from 0 to infinity. That's a
Okay.
kind of a side point, and that's something that comes up with this problem. Now, do you remember how to solve 2 natural log 3x plus 1 equal to 0?
No, I have no idea.
Okay. All right. I like the at least you didn't try to say, oh yeah, I've seen that before. Subtract 1 from both sides. 2 natural log of 3x equals -1. Divide by 2. Divide by 2. So you have natural log of 3x equals -1/2. You undo ln with e.
Oh
So you have
yeah.
3x equals e to the -1/2. Divide by 3. So x equals 1/3 e to the -1/2 power. So that is on the number line here.
Okay.
And this is again, this is one of those problems where if you're not comfortable with like your prerequisite stuff, like you may not know, well, what's here or what's here without, a calculator.
Yeah.
Are you generally allowed to use a calculator?
It depends. If he doesn't make anything too hard where we would like need it.
Okay. This one's
Um,
probably not in the realm of like you probably wouldn't get this because of the of this, but because the worst part is now you have to put it back in. You have to kind of get a sense of, well, is it positive or negative
yeah.
and things like that. So um let me go see if I can find some other examples here. Um,
Okay.
the one that I was thinking of is, which is kind of like your problem there, is they restrict the domain of sine and cosine is the more common way to do it. So
Okay.
let's look at, I don't know. Actually let's look at 27. Let's do another polynomial.
Okay.
All right. Could you take a derivative of this, please?
30x to the fourth power minus 30x squared.
All right. And what is the GCF? What is
Mm,
the GCF?
isn't it 10? 30. It's 30.
And then x to what power?
The second.
Okay. So what goes in parentheses now?
Um, x squared minus 1.
Okay. So now you set each of these equal to 0. 30x squared equal to 0. X squared minus 1 equals to 0.
Okay.
Could you attempt to solve those?
Yeah. Um, I know that x squared minus 1 equals x to the square root of 1
There's actually two solutions though. And there's a
plus
couple
or
of
minus.
reasons. One is its difference of squares. Yeah. The other is that it's x squared equals 1. So it's plus or minus the square root of 1, plus or minus 1. How about the other
Okay.
one?
I have no idea.
So you divide by 30. That goes away. So it's x squared equals 0. N squared is 0 is 0. So this becomes x equals 0.
Okay. Okay.
So on a number line here, -1, 0, and 1 are your critical points. So this is tough to for most students. Your derivative is 30x squared, x squared minus 1. So let's test some points. The easy ones to test are out, obviously out there like 2, but the ones in here more difficult.
Yeah.
Okay, so let's do the easy ones first. Tell me when you put 2 in, is it positive or negative? What's the sign here?
Um, it's positive.
It's positive, yeah. Now, 1/2 squared makes 1/4. -1 is less than, it's negative, but 1/2
Okay.
squared is positive. 30 is positive, so it's 30 positive times whatever that is that's positive times a negative becomes a
Negative.
negative. Yeah,
Yeah.
okay.
And then it should be opposite for the -1/2, right? So it'd be positive.
Well, squared, it's squared here, so
Oh,
that becomes positive, but then when you subtract from 1, it's negative,
so it's
so
negative.
it ends up being negative. So that's the mistake of thinking that, oh, they just alternate.
Yeah.
-2, what goes here?
So -2 squared 4 positive times it's positive.
Yeah, so they could ask you now, like, where is it increasing? Where is it decreasing? They could ask you if there's a min or a max. So it's increasing when it's positive. So that's from -infinity to -1, comma 1 to infinity. Decreasing from -1 to 0, 0 to 1. So that critical point, it's neither increasing or nor decreasing. That's why it's excluded.
Okay.
And then where is the min? Where is the max?
The min is at 1 and the max is at -1.
Yes, good. And if you wanted the actual min or max value, you'd have to go all the way back to the original for that.
Infinity.
Yeah.
Okay. That makes sense.
Okay. So let's look at 31 now.
Okay. So
You have a question?
no.
Okay. So this is the graph. And could you tell me by looking at the graph where any horizontal tangents exist?
At x equals 2.
So over here.
Oh wait, -2.
Okay. All right. Yeah. Big deal. Yeah. Now, um, how would you describe this to a non-calculus student? What's going on at 0? Like someone who doesn't
um,
understand. Go ahead.
I would tell him it's a cusp,
Okay.
but
So what it like, give me now a little bit more mathy of a language. What does that mean?
I have no idea.
Well, you did well. It is a cusp. What does the derivative tangent line start looking like there?
um, a horizontal? Oh, no.
What's the opposite of horizontal?
Vertical.
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 Yeah. Yeah. Now, the other thing is, uh, are the slopes from the left the same as the right?
No. Well, for this one, maybe.
No, no. Well, like what, like they're approaching, like, yeah, they're both, this one is fairly constant, but yeah, there's an issue here with the slopes. So that's good. So you've done everything. To answer my questions, I feel pleased with what you said. I think you're doing better than most in terms of answering this. Okay, could you take a derivative of this function for us, please?
Uh, yeah. Um. Wait. How to do the x to the 5/3? Oh wait, never mind. Never mind. That was stupid. Okay, I got 5/3 x to the power of 2/3 plus 10/3 x minus to the power of -1/3.
Okay, so this is the challenging part here is figuring out how to um solve this for x. Like we know it's at 2,
Yeah.
okay, but how do we like show that using algebra? Any ideas?
Mm, no.
Okay. You're still going to factor. So let's say you factored out 5/3 x to the 2/3.
Okay.
So this would be 1 plus, and then any idea what goes in here?
5/3 x. No, I actually don't.
Okay. So there's this thing, they call it divide and slide. You heard that before?
Nope.
Okay. Well, when you divide by I didn't make that up. That's a future thing. I don't really like it, but that's what they say. So the exponents, when the bases are the same, you subtract the exponents.
Okay. So it's equals 1. -3/3.
Yeah, so it's x to the 1, and then there's a 2 right there. 2x to the -1, like that.
Mhm.
All right. So if you set these equal to 0, 5/3 x to the 2/3 equals 0, and then 1 plus 2 over x equals 0. The first one is a critical point at 0.
Yep.
What about the other one?
Um. So be 2/x equals -1, and then I don't know how you would multiply the x on the bottom. So like whenever I get 2x or 2/x equals -1.
So you can diagonally multiply here, 2 equals negative x, so x equals -2.
-x. X equals -2. Okay, so my critical points are 0 and -2.
Yeah, now there's this other issue, which is, I guess your class is addressing that, but since you have the graph, you can tell me what's going on here without trying points. Like it's increasing, it's decreasing, it's increasing.
Yep.
And so you already know that that's a max at -2 and that's a min from the graph, but now you can see it. You can see it from there.
Yeah.
Okay, so
And
let's talk about what?
I have a question. So are all the critical points for like the graph of x and the graph of the derivative of wait, are all the critical points for the graph of f and f prime the same, or are they different?
I guess could you try asking it just again in a different way? I'm not quite following.
So like if there's a critical point for like the original graph of f,
Yes.
are those critical points the same on the graph of the derivative?
Yes, exactly. Yes, that was the
Okay.
whole point of this problem is that you knew ahead of time it was at -2, not 0.
Yeah. And then we found it using the derivative. Okay, that makes sense.
So did you guys talk about inflection points?
Yeah.
Okay. Can we talk about those now, or do you have problems you specifically want us to do on the,
No, I'm good with that.
all right. I'm just looking for some problems here.
Okay.
Here is problem, typical problem. They want to know not just not just inflection points. They want to know concave up, concave down. The
Mhm.
recipe, the procedure here is really similar to what we did for critical points, except you have to take two derivatives here. Could you take two derivatives and give me your result, please?
Yeah. Okay, f double prime of x equals negative 6x minus 24.
Yeah, that sounds right. Okay, now when you set that equal to 0, could you solve for x, please?
Yeah. X equals negative 4.
Okay. Now this time you are testing points, but you're testing them in the second derivative,
Mm-hmm.
and you again only care about the sign, whether it's positive or negative.
Okay. So, negative to negative. Uh, the negative 5 point is positive because 30 minus 24 is 6. And then 0 is negative.
Now, the only time you get a inflection point, an IP, if you will, is when you go from plus to minus or minus to plus.
Okay.
That you're guaranteed. You don't have to do anything else. Now, sometimes they want to know the like the coordinate of the inflection point, and you're gonna have to put that -4 back into the original.
Okay.
It's concave up. There's more definitions. Concave up when the second derivative is greater than 0. It's concave down when the second derivative is less than 0.
Okay.
Those are things you just have to know.
Okay.
Okay, so let's see here. We ought to look at trig function or two. So let's just look at a basic one. Let's say y equals sine of x, and we're only looking from 0 to 2 pi. Uh, that doesn't matter. We can do that. Okay. Um, so derivative, right? Y prime here. Derivative sine is cosine. Derivative of cosine is minus sine x. Do you remember where that's equal to 0 on the unit circle?
Uh,
Sine is the y
0.
value.
So, uh, wait. Whenever x equals 1, or whenever x equals 1. Is that what you're asking?
Sine is the y value.
So when x equals 1, right?
Yes. Yes.
Okay.
But also when x equals -1.
Okay.
Your answer was like half right. So I was hoping I'd hear something. I always give more time. So
Yeah.
it's what are the two angles that are there in radians?
0.
Okay. And then the,
And I don't know what the other one is, I'm gonna be honest.
okay. How much trig does your teacher give you?
Quite a bit.
Okay. All right. So now on our number line, again, it doesn't go from infinity to, it goes from 0 to 2 pi because, well, that's what we started with. And then there's a critical point right in the middle.
Okay.
So that's, I'm sorry, not a critical point. That's a possible inflection point. So now you have to test something in the interval there, and you're testing it in the second derivative. So sine pi over 2 is the y value up here. The y value up there is 1. You negate it, that's negative. 3 pi over 2 is the y value down here,
-1, and then you
which
negate
you
it. So
negate it. So this is an inflection point at x equals pi. That's like the most basic,
yeah.
uh, type of problem you could get. The
Okay.
the rest, like the homework problem, everything else is the same. It's just, the complexity increases depending on what kind of functions you choose.
Yeah.
All right, let's see if I can find more problems. Are these problems at all like what you're seeing in class or something different?
Yeah, they actually are. Definitely.
Using a derivative to analyze functions. All right. Why are they not? All right. Let me go back to your book.
Okay.
Okay. Let's look at this picture top right here. It's figure 8-2Q.
Okay.
Give me the approximate or exact x values of any critical points.
Um, x equals 1 and x equals 0 because it's a plateau.
Okay. Any places where you believe there to be an inflection point.
Um, isn't it like x equals 1/2 or something? Does that work?
Um, that there's one there. I would argue there's also one at 0. Kind of goes from being up to then being down.
Yeah. Okay.
And then also
Negative
um
1/2.
1/2 there. Like you said, like it looks like there's probably one there.
Okay.
Okay, now you had previously found the derivative of this function to be 30x to the fourth minus 30x squared. Could you take another derivative of this for us, please?
120x cubed minus 60x.
So this time you can factor 60x out of both and you get x 2x squared minus 1.
Okay.
No, is that right?
Mm,
Yeah, it looks right. Um, yeah, it's not, it looks like it's 1/2. We're gonna see it's slightly different. So when you set the 2x squared minus 1 equal to 0, you get x squared equals 1/2, and the square root of 1/2 ends up being root 2 over 2, which is kind of plus or minus. So there's actually a second one. I don't
okay.
see that, but they didn't give you the full graph here. So anyway, the point is that sometimes you can't really do it from the graph. You have to go down the steps here of doing
Yeah.
this. All right. So see if we can get through one more problem. Um, let's do everything on this. So let's have you find the first derivative of this, please.
Okay. So e to the negative x plus x to the, wait, e to the negative x. Can I bring the negative down? So it's like e to the negative x minus x to the e to the x? Or do I have to keep the negative with the x?
Days with the I guess I'm not sure what exactly what you're saying. Like, but like the answer has an e to the minus x in it.
Okay, well then I got e to the negative x plus x or minus x to the e to the x. Does that work?
It's a minus in here because the derivative of e to the minus x is minus.
Okay. Then keep the negative here. Okay.
Okay. So now when you set this equal to 0, what can you factor out of both?
E to the negative x.
Okay, and you're left with 1 minus x in here.
Okay.
So where does that equal 0? And e to the minus x looks like this. It never equals 0.
Okay. So x equals 0 at negative 1.
Positive 1. Positive 1.
Oh, yeah.
Okay. Now, could you take a second derivative here for us, please? You'll notice
Uh,
quite some similarities.
e to the negative x. Hold on.
Negative e to the negative x. Chain rule.
Wait, oh, yeah. And then,
So here, let me give you a little hint here. Um, this right here, x e to the minus x, is the original function. What was its
yeah.
derivative? You
So
just
e to the x minus, oh, yeah.
so if you take calculus, well, it's differential equations, but you do this a lot in differential equations, and the more you notice stuff like that, the faster you will be. So uh, you know, every little bit helps here. Minus 2 e to the minus x e to the minus x. What can you factor out of both?
E to the negative x.
This becomes minus 2 minus x equals 0. Could you solve that inside part for us, please?
Yeah.
Set that equal to 0.
So x equals negative 2.
Yeah. And so you'll find that that ends up being an inflection point.
Okay.
And this up here was a critical point.
Okay.
Okay, we're going to stop there for today. Stop